Right, this is going to be pretty quick because I've been informed I have a low amount of time. Earlier I talked about variance in the V coming up here in V10, and since that's my project, I can talk pretty formally about it. One of the things that I typically do is I like to show and tell, but because I just started working on the UI stuff, it's going to be a lot of tell and not a lot of show. I'm just going to tell you how it's going to work, but I'm not going to be able to show you. There's a few screenshots. They're very preliminary, so don't get too hung up if the final version doesn't look like this. But I'm going to just talk a bit about variants and what they mean in KiCad. So, what's a variant? A variant is pretty simple. It allows you to create an alternate bill of materials, a schematic, attributes, and footprint populations in a single PCB design. And they literally represent a difference between what you now know as the base schematic. What you're working with now in KiCad, you get one schematic. It is that one, right? So you'll be able to create diffs against that schematic, and you'll be able to create multiple diffs. So you can do things like interesting stuff like multiple PCB assemblies of a single PCB. Like maybe you have feature A, B, and C, and on the high-end version you populate all three features, and then in your stripped down version you only have one feature, right? Those are pretty common things to do for people who are in commercial manufacturing. You can have components with different values. Something like I have a 10K resistor on this one, a 50K resistor on that one. You can add and remove optional circuitry, which is the DNP. That's the population things. You can have multiple footprints per symbol with some restrictions. You might have 3 different size transistors for an open collector output, one low power, one medium power, one high power, right? But there'll be some restrictions on that. And you can control simulation. Maybe in one design, in one variant, you want to simulate this part of the schematic, another variant, you don't. So there's things you can control in variants. There are things that you can't. So what can you change? You can change properties such as do not populate and do not simulate. Those are properties that apply to both sheets and symbols, right? So that can be varianted. Symbol fields like the value field, footprint field, any user-defined fields that you will be able to create variants of. Sheet properties such as do not populate and do not simulate. Those are also variants. User-defined sheet fields are variants. Changes are per instance. Now, before I go much further, the word instance starts in. Who here knows or is familiar with what instances are in KiCad? Okay. Well, that's good, because our next question was going to matter. How many people understand instances? And everybody's hand would have went down. So in KiCad, an instance, you've seen them. When you look at the hierarchical, in the hierarchical view, it's the tree that shows all your sheets in a hierarchical view. If you see those paths that look like / sheet name, / sheet name, / sheet name, / sheet name, those are instances, right? Why do we have them? Well, if KiCad only allowed you to have a one-to-one representation of a sheet and a schematic, in other words, we wouldn't need them. Everything could be contained in the schematic and it wouldn't matter because it would never vary. The problem is in KiCad is we allow you to reuse that same schematic file over and over and over again. So now the instances change because those sheet paths change. Each one of those full paths that points to that file changes. And that's an instance. That's what an instance is. So anytime you start sharing reusing the schematic more than once, whether it's in the current design or across multiple designs, you're going to end up with instance data. So that's an instance. That's the 10-second ticker. So variants are directly related to instance data. So, and they have to be. So, what can't you change? Well, basically anything that would make your board a different design, right? You can't, right now KiCad doesn't support multiple boards. So anything that you would make the board different you can't change. So for instance, exclude from board property. You can't change that because if you add that symbol to one board or footprint to one board, but not another board, that's a different board. Same thing with reference designators. You can't have 4 different reference designators for the same footprint in KiCad. You have one. You get one reference designator. The sheet exclude property, same thing. For the same reason that you can't use the symbol exclude property or exclude from board property, you can't use the sheet exclude from board property. Sheet names and sheet file names, that's effectively a different design. So those 4 things right there, you won't be able to make a variant of those things. That won't be available. But virtually everything else for symbols and sheets, you'll be able to create a variant of. So variable naming, well, you can use in KiCad, we pretty much use strings. The variant naming will be anything you want, any printable character, with the exception of line feeds, because a name is going to be limited to one line. You can't use a paragraph as your name for a variant, and you wouldn't want to for a lot of reasons you'll see later. File name limitations apply. You'll be able to use file name characters in your variant names. The only limitation is when those variant names will probably get suffixed to your, like when you output a file, like it's bomb variant X. If there's file characters in there, illegal file characters in there, it's going to substitute an underscore. So kind of things you got to think about when you're naming stuff in KiCad. KiCad, by definition, most places is case sensitive. So foo, capital F-O-O, does not equal F-O-O. So there will be ERC checks to check for, we have similar ERC checks where we check for, hey, you got this one and this, like label names where you have capitalization differences in label names. There will be a similar check for the variants, but you're allowed to do that. Those will be different variants in KiCad. So we tend to stick with the POSIX, foo doesn't equal foo, just because of capitalization differences. Null variants. What's a null variant? Well, here's a simple example. My original schematic is a 1 k ohm resistor. In my variant, I say, okay, I want that resistor to be 10K. And somewhere along the line, I'm not paying attention, and I changed the base symbol to 10K. There's no diff anymore. So the variant will go, that's a null variant. Because if I plot it, like say if I generated a bill of materials for that, well, what would be the difference? I would get 2 identical bill of materials. It would both be identical. So a null variant is a variant that doesn't have, that there's no difference from the base design. And basically those get not saved. So it looks, so as the variant system is saving the files, it will say, oh, there's no difference between here and me and this other one. I'm not going to say that because it's not a diff. So keep in mind, that's a limitation with the variant system. Field limitations. If the base symbol doesn't have a field or the sheet doesn't have a field, you can't do a diff on it. It has to have a field to do a diff again, like a manufacturer's part number. You can't have a manufacturer's part number field in a variant and not in the base object or the base design. Footprint field limitations. So if you're going to define a symbol with multiple footprints, there are some limitations. The pin numbering on every footprint that you assign, or every variant that you assign to that symbol, has to have the same pin numbering as the symbol. Otherwise, it won't be able to do the network, or won't be able to do the net connectivity in the board editor. So you can't have like a 6-pin footprint mapped to a 3-pin symbol. You have to, if you got 1, 2, 3 on your symbol, you're going to have footprints with 1, 2, 3 pads so they can map correctly. They will have the same reference, however, because only one of those in a variant footprint, only one of those is populatable at a time. You couldn't populate all 3, like if you had 3 like my transistor example earlier, you can't populate all 3 transistors for a board, or it's not going to work real well. So those are the limitations on footprint variants. You can have one unpopulated per variant, and every variant footprint has to match the symbol pinout. So create a new variant. There's menus. I didn't get a chance to make screen recordings for this, but in the tools menu, there's going to be a variant. The variant management tools are going to be in there. Create new variants. It's going to be a single line dialog, you add a new variant. Same with deleting a variant. It'll open up a list box. You can delete one or multiple variants at the same time. The default variant is always there. You can't delete it. It's permanent. It's what you have now. It is what it is. Variant selection. So as you're editing, boy, it turned out kind of light. If you notice all the way right, this is the schematic editor toolbar. There's a drop down. Right now it says default. That's where you'll select the current variant that you're working on. So you can change that variant to whatever variants you have available, or where you add a new one. Say you want to change variant 1. Everything that you work on, all the symbols that you modify, all the sheets that you modify, will modify the variant, not the original. So I still have to bat some ideas around here, but this is one way that you'll be able to edit things. That means anything that like any fields that you edit in the properties panel so you'll be able to select multiple symbols, click a variant name, and then edit multiple fields at a time if you'd like to. That's kind of how you have to do it now with KiCad, even if you're working on the base design. So that's one way to do it. It's not the ideal way to do it. The ideal way to do it, like a lot of things when you're working with symbol fields, is to use the symbol fields table. Most of us are, if you're doing, lots of bombs and stuff like that, you're familiar with this dialog where you go in and edit. So you notice down there I've added, there's now a variant. This allows you to add variants right here and change everything in this dialog without having to do the one at a time thing in the schematic editor. So this allows you to bulk edit variants. And so the way this would work is the variants that you have selected, the changes you make will affect those variants, right? If you don't have any of them selected, it's the default. Or if you have default selected, it's the default. But so you could add, delete, and rename variants in this dialog. Conversely, if you go to the export tab, which is where you output your bill of materials, you can select which variants you want to print out, right? So if you want to print all the variants, you just select all of them and you'll get, in this case, you've got 3 variants, you'll get 3 bill of materials, 1 for each variant. So it's pretty straightforward. I don't think there's anything magic or special about this. It's just some things you have to be aware of as you're working. So that's the editing part of it. And same thing in the schematic editor, when you export to the board editor, instead of having one footprint for that symbol, you have however many variants you have, but they'll be wired in parallel. So pin 1 to pin 1 to pin 1, 2 to 2 to 2, 3 to 3 to 3 in my transistor example. So you create variant bombs, as I discussed earlier. So using the field table editor, of course, you can export a bomb other ways. But when you do it like one at a time from the export bomb menu, it'll be the current bomb you have selected in the schematic editor. So if you have variant 1 selected, you're going to get the bomb for variant 1. Of course, that's why we have the command line tool or the job sets available. So the command line interface, there'll be a new option called variant, obviously. And if by default, if you leave this unset, it'll be the default or the base design. This could be either a list of variant names. Maybe you want to print out 3 or your 4 variants, or all. So if you use the all keyword, you'll print out every variant. And right now, the way it's set up is it will suffix, at least for these, it will suffix the name of the variant to the, or append it onto the end of the file name. So you'll get project, variant name, whatever file format, CSV or whatever file format you want the bombs to. This also applies to all of the other outputs where variants matter. PDFs, anything where the information on the export would change. So PDFs, SVGs, PostScript, you you'll be able to include a variant or a list of variants. So you either get one or multiple PDFs, one for each variant. So that's available, will be available in the command line interface. It will also be available in the job set. If those are for you familiar or not, we have this fancy job set where you can set up complex outputs. The same option will be available in the job sets that are available from the command line. You can print one or multiple. There you can probably do some more complicated things, like I think we're going to add a variant name variable that expands to the variant name. So you can use it for other things internally if you would like. One thing I've been thinking about, so this gets back to the instance data. This is obviously a simple 2-sheet schematic, right? One of the things I thought might be interesting is editing variants is it's sometimes a little abstract in the way not only KiCad implements it, other tools implement it that way too. And it might be interesting to flesh out the hierarchical tree editor or hierarchical tree viewer and turn it into an editor where under each instance you get the schematic and the things that you can change. So in there you could add a new variant and change from the default. Let's say you wanted a variant of a 1K resistor there and you change the variant to a 10K or whatever. So you can actually see where in the schematic that gets changed. That's particularly important for as I was mentioned earlier, shared instances where you share a schematic across multiple times. Because sometimes it's hard to conceptualize. You're actually in the same schematic, but it's a different instance. So I have some ideas there. Still need to bat some ideas around with the development team, but that looks like might be a more concrete or obvious way to edit variants. But there's definitely some work to do there in terms of the future. I think initially this part might not make it into 10 because it'll be pretty heavy load or heavy lift. But all the main features that came before this will be in 10. If you have any ideas that make variant editing more obvious or concrete, I'm always open to a suggestion. But that's about it. So I apologize for this not being more complete. This was kind of like foisted on me for it pretty quickly, and then it went away, and then it came back. So, anyhow, that's about it for variants. It's not a particularly complex topic, but it's a very useful tool, especially if you're doing a lot of same as except type design work, which I've done in a previous lifetime. So you have one design, multiple populations. Variants are a real important tool. And it's been one of the probably missing parts in our portfolio for a while, but it will be available in 10. So thank you. And do you have any questions?
Yeah, so last year, Mark presented his KeyVar tool, right? Could you comment a little bit on the similarities and whether it's that what is supposed to replace that, or?
Yes, and I don't want to say no because it's different, and that was a plugin that does some things that internally in the KiCad file structures that KiCad would not otherwise do. It's like a pseudo. It works really well, right? But it requires some syntax gyrations to make it work that this won't. This will be much more straightforward when you're working on a variant. But I mean, that's a great tool. I mean, if you like the way it scripts out stuff, I mean, by all means, you should continue to use that. But yes, I think eventually we'll be somewhat replacing, or there'll be a lot of parallel functionality. So you have to decide for yourself if you want to continue to use KeyVar or if you want to use the internal variant implementation. Now, I don't believe KeyVar allows you to do multiple variable footprints, though. Does it? Does it allow you to do variant footprints? Oh, okay. All right. Yeah, I knew it was real useful for bomb variants, but yeah, I wasn't familiar with it.
A simple question: how does variables footprints work? Because you have one PCB which is connected to various circuits, circuit diagrams. Your PCB remains static. That's the one.
Mm-hmm.
So, for example, if I'm going to put on a TO220 and a 20247 package, where am I going to put the silk screen? I'm going to put the silk screen on what's going to be.
It's going to be in one. Yeah, it'll be in one place. Well, I'm guessing that all three of those transistors will be close to each other. You won't lay one out across the board. I mean, you could, but yes, or maybe there will be a U2 multiple. Like if it's U2, it'll be three U2s.
The second question is: are you planning to use to have the different step files for different variants?
Yeah. So it'll be tied. Well, right now it's step tied.
Yes, obviously.
Yes, step files are tied to the footprint, not to the variant. So by default, when you pull in the other, like a TO220 versus a TO2, right? They obviously the footprint defines what the 3D model is, not the symbol. So yeah, they'll just come in with it, right? And then when you say do not populate, when you open the 3D viewer, it just won't have. It'll only have the one that's populated. And then each variant of the board will be viewed correctly, right? Because you can't put all three of those transistors in at the same time. You're going to have two of the, like, let's say in my case, there was 3 variants. For every variant, 2 of those are going to be a DNP and one of them is going to be a populate. Right. Yeah. Because it is the same reference, that it's the same part. Another example is you have a DIP 8 and then SOIC 8. You can put those in, like, you can actually sit those inside of each other and map them 1 to 1. You can't populate both those at the same time. It's one or the other, right? But you can have both footprints there and wire them up in parallel. So yeah, that was the limit. One of the limitations with footprints. You can only have one at a time.
But the copper pads will all be present of all the possible footprints.
Yeah.
So that is the board layout is the same, but only one of them is going to be populated.
Well, yeah. So in the variant, there'll be a check. If you have, let's in my 8-pin case, if you have both parts, there's going to be an ERC check. If both parts are populated, it's going to say, hey, you're both variants. You're trying to populate this at the same time. You sure you want to do that? Probably not going to work, but yeah.
Okay, so if there are variants that have 2 footprints, so I can decide between 2 footprints for one and the same symbol.
Yeah,
I have both footprints in my PCB layout, and I can decide by myself if I want to overlap them or have them side by side.
Well, yeah, you can lay them out, orient them.
Okay.
They have to be 1 to 1, right? And then they have to match the symbol, because otherwise you wouldn't be able to create a net list, right? But yeah, you can wire them any way you can wire them any way you want, but you can't populate more than one at a time. In other words, well, you could, but I doubt you want to, right? I mean, I can't think of a case where you would actually do that in production. Maybe there is one, but typically in instances like that, at least the examples that I've given, and that you couldn't, you're be highly unlikely your design would work.
Okay, so I'm the author of KiCad, so thanks for your words. One thing that I would like to be able to change in KiCad is the database reference, database symbol reference, so that I can choose between different parts or database symbols. Will this be possible with variants, native variants?
Well, I mean,
will I be able to switch to a different database symbol when choosing a different?
Sure. I mean, variance doesn't really affect the symbol. So you will be able to, if you wanted to pull your symbols from a database, like using the database library I don't know how many of you are familiar with the database libraries that we support now.
Because if I can only change the fields for a specific symbol, then that's not the same as switching to a different part or database symbol.
Right, because you could make a variant. I guess you could pull a variant from the database. Not initially, it won't be able to do that now. But you could pull a variant from a database as long as the symbol's identical. Yeah, you can't change the symbol because the symbol's a different. Because remember, a symbol, the graphical symbol, the pins, that's really only part of the symbol, right? That part isn't variant. It's all the fields with the exception of the reference field. And you also can't use a different unit number. I forgot that one in there. I mean, that would change the design.
Okay, thanks.
Well, yes. But change all of them. Yeah. When you update the board from the schematic, it'll just get the new references, just like it does now. Except instead of one footprint, there'll be X, however many footprints you made variants.
I had a question about going back to the previous presentation about design rules. Does it also mean if you have the variants that if there's different footprints that you can specify different design rules depending on the footprint? For example, as you mentioned, different powers or different size packages. So if you want to have more current, you would need a thicker trace on the PCB. Will it connect those things automatically, or will there be an option to, because it's the same net?
Yeah, it's the same net, so it would be hard to do. Everything's done by net. Yeah, so that would be tricky. That might be a manual operation that you would just have to. I don't think we do in the case of like a power transistor. Yeah, you would have to think. I mean, maybe we could do it by variant. I mean, right now I don't think there's a design. Right now there's not a design rule for like variant A. If variant is equal to this, use this. If variant is equal to that, use that. Variant A or variant equals to variant 1, then this footprint gets X width trace or your minimum width trace or something like that. Yeah, right now I hadn't thought about that, but that's something we can look into. I don't know if I'll have that. I'd have to talk to somebody about modifying the rules editor, because right now I don't think I know there's no rule for that. So, but we could probably create one.
Thank you, Wayne, for working on variants. I think this is one of the most wanted features for almost everybody in here. Going back to database libraries, as far as I understand this, changing resistor in a database library is a new part. It's a different part, because in the database library there is the resistor, and it has like a value, and it has MPN, and it has my internal number. So if I want to change the resistor from 1K to 12K, it's another part, if I'm correct.
Well,
so will this be possible with variants?
I have to talk to John a little bit about that, but what you could do is create variant. So you could literally pull, as long as the symbol is the same, you could just say, I want to create a variant from the database, and it'd say, okay, yeah, it's the same symbol. And it just makes a new variant and populates it with all the field information inside the database. I mean, that would be something pretty simple to do.
Yeah.
So if you have a database library set up for your at work, which I'm sure a lot of people do, you just say, okay, oh yeah, I want to use maybe you have an internal SKU number for your own internal parts, or maybe you just use the manufacturer part numbers. I know everybody does something different in that case, but you just go pick that SKU, and it just says, okay, this is for variant 1, this is all the fields. I'm just going to replace all the fields with what's in the database, right? So as long as the symbol's the same, all the other information from the database can be populated as a variant.
Second question, I also like the notion that I have a symbol and I can have various footprints assigned to that. But I'm a little bit wondering how you'll do this in the program, because actually the way I did this is I just put several transistors side by side and I said just DNP whatever I didn't want to, and it's pretty straightforward. So what happens if I delete a variant with a certain footprint? Will it go away from my PCB?
Yes. Yes. If you delete the symbol, all three of them will go away. But if you delete a variant, all the footprints associated with that variant will go away. Because remember, when you do an update PCB from schematic, everything that's gone from the schematic. Now, you can disable that, right? Right now it says, I think there's an option that says remove footprints that aren't in the schematic, right? You can leave them there. But eventually, when you sync again, you're going to have to reconcile the fact that your board doesn't match what your schematic is telling you it should be. So either you have to maintain that outside of the schematic, which is always risky. Yeah, but we allow you to shoot yourself in the foot. That's always one. That's because one of the things that we find is if I try to make things too restrictive, people get upset. So I'm more than happy to allow you to make that kind of mistake, but that's on you, right? As a developer, you have to take some responsibility for that kind of flexibility, right? It's always a trade-off, you know. But I find that more often than not, people are happy to take. They don't like the restrictive part, right? They don't like to be told, you can't do that, you know. Why can't I do that? Okay, you can do that, but that's on you. But yeah, so like I said, is anytime you have a mismatch between the schematic and the board, it's going to complain. The DRC is going to complain, hey, I got a footprint, it's not in the schematic. You know, it's just the way it's going to be. But yeah, if you update from schematic and you have the delete footprints that aren't in the schematic, that's going to go away. If you have a variant and you've accidentally deleted it, it's going to go away. But there's always the undo command too. What's the addition? Yeah, it's Q. No, they're all Q1. Every one of those will be Q1. But bill of materials. Well, I guess we can do Q1 variant, but we can maybe suffix them with variant. Yeah. Yeah. Well, it's probably chances are if the bill of materials is a TO220 and they're trying to put it on an SOT23 pad, I'm guessing they're going to have trouble with that. They're going to figure out it goes in the. But yeah, I guess I have to figure out a way to suffix that. But yeah, we could do something like that.
Hi, yeah, so thank you for variants. This is very important. You mentioned that CLI, and I was thinking about, because using variants is making board more complex, and I was thinking about if it is possible to pipeline this, to run this on a pipeline, this variance parameter, and do some tests and checks like ERC, DRC, checking of a bomb. Is it possible to use it with the variance CLI that you've?
Yeah, so if you want to run a DRC on a variant or output your step files for variant to like Verve manufacturing, yeah, you can do. You're going to be able to the variant in the command line options. There's variant. Mm-hmm. Everything that a variant will affect, that'll be there, like a step file. If you populate one of your footprints, you'll get that step file. If you populate the other footprint,
so it would be difficult.
The other one, you won't get both. You won't get both footprints at the same time. It doesn't make a lot of sense.
So there will be multiple outputs that I can use to test and verify then afterwards. And
yeah, it's somewhat similar to a bill of materials, right? I mean, the bill of materials is going to change depending on your variant. Well, it's same way with your fabrication outputs, right? If on one variant it's a DNP and on the other variant it's populate, and vice versa, you know. So every time you output a variant, whether it's a step file or some other documentation, you will get the correct variant information for that. But it has to be separate documents, right? Because they really are separate, just like they're separate bombs, bill of materials. Does that make sense? Okay.
Hi, where will those variants be stored? Only in schematic or in the board too?
In the schematic, they'll be available in the board. It'll be somewhat limited when you run the, if you run from KiCad, which is a single binary, then everything's always available. So the board will have all the variant information, but saving it both in two places might be problematic. I kind of want to avoid that. We might have to, but I'm not sure that it's really.
We are using our own schematic entry. We're using our own schematic entry at our company.
Okay.
And we're using a netlist importer to get for the layout. So the variants will not be available in the way we work.
Oh, so you don't use this? Yeah. So I guess I can.
Or if I switch the variant, my resistor from 10K to 1K, I always have to do this over schematic, not in the layout editor. Can I switch the variants in the layout editor?
In the board layout area?
Yes.
No. The variants are driven from the schematic.
Okay.
Yeah. The master control for variants is the schematic, or the definition of schematics or the variants is in the schematic, and it gets pushed to. It's similar to how all the other information, like what footprint, that information is actually driven by the schematic, right? So when you update the board from the schematic, then all that information comes across. But yeah, I don't think I'll store it separately because I think keeping it synced is problematic. If it becomes an issue, I guess I can reevaluate that later. But initially, because it's always available. I mean, if you run KiCad, rather than running EE schema separate. So if a lot of you, I don't know if you're familiar with this, if you can run EE schema and PCB new in standalone mode, right? There's actually features missing right now because the IP stack where we pass stuff back and forth is limited to certain features. And I don't think everything is fleshed out, right? But when they're both running from the same instance, which is when you launch them from KiCad, even though it looks like they're two separate programs running, there's not. That's a single binary. So everything's available all the time through both editors. So it's easier to move, send information back and forth when you're running from KiCad rather than running them as these standalone binaries, which I think at some point are probably going to go away. We're just going to emulate standalone mode because it's a bit of a maintenance issue for us. But yeah, to answer your question, no, at this point, I don't think we're going to save all that information to the board and the schematic.
Netlist, it's per.
No.
When you export the netlist, it's per variant. If this variant, he's exported the netlist and he's loaded that into his. You were talking about working with netlist direct. You in the variant, you create an export to netlist that's going to send the footprints of that specific variant.
Right.
He's going to import the specific variant.
But that's actually the information in the symbol, not the net. The net list doesn't change. The net list is fixed, no matter what the variant is. What changes is the fields that get. So when you update a footprint from a symbol, the fields get updated, not the variant or not the net list. The fields that go in the symbol change, but the actual connections between points don't change. But yes, they're embedded in the net list and they're embedded in the symbol definition. But it doesn't change the actual nets themselves. Those are fixed. But yeah, you can pass them across and print them out as and the objects inside, but it'll just pull that from the schematic editor. You ever notice when you do something in the board editor, it opens up the schematic editor for some unknown reason? Have you ever used that? You've been doing something in the board editor and all of a sudden, like run DRC. If you run DRC and it says synchronize from schematic editor, it opens up the board editor. That's to get the information from the board. So that a lot of that, because we don't store that information in the, in the board. So to sync back to the, so you'll be able to maybe select a variant, but it's going to open up the schematic editor and say, hey, pull that variant and then update the board view. But because that's just really a view. It's not really a change to the board. So you'll get like all the fields will change, like the value fields will change. But most people who use variants don't put a value field on like a resistor because otherwise somebody's going to get confused. If you put 7K, like let's say R2 is 7K, put 7K there and then one of your variants is 10K. Well, wait a minute. So you just don't put any value on you don't show the values silk screen because otherwise that's a different board. As soon as you change the silk screen, that's a different board. So remember one of the limitations to variants is it can't change the board. Can't make a different board. So I think that's true of most EDA tools, unless they support multiple boards, and then each board's a variant. But yeah, that's not what this is in this case. Any more? Are we out of time? Okay, one more and then you guys want to start bringing up some chairs?
So if I take the variance for a use case where I have one board with 3 different versions in case I don't want to populate things. Now, a few years later, I have the case, some of my parts are discontinued and I want to have a new one. Do I need to do the change on each variant or there is a version to propagate one change to all variants?
Can you explain that again?
So I have one schematic and there are parts of they say functional blocks. I want to distinguish the versions. There is one that has all functions and other has only a few functions. And now, sometime later, I want to change one part, but this one part I want to change on all variants. How would I do this? Do I need to change it manually on all variants or?
You want to change the part on all the variants. If the part doesn't have it, okay, the answer is it depends. If you don't have any variants for that symbol, then you only need to change the symbol in the base design, right? If there are no variants for that particular symbol, okay?
I mean a symbol that it's on all variants the same.
Okay, if there are variants for that particular symbol, and let's say it's an obsolete part, then you have to change it. Now, once again, the answer is it depends. If you're going to make that same for all the variants, well, that means that variant doesn't exist for that symbol because all of the symbols are the same, right? Does that make sense? A variant literally means a diff. If there's no diff, it's not a variant.
Okay.
Right? So if you in the editor, if you select all the variants, including the default, and you change a value field to 1K, all those variants for that symbol go away. It's 1K for every variant because there's no diff. It's not a variant if they're all 1K, right? Mm-hmm. If all the fields are the same. Now, maybe you have a 1K and it's this part number and a 1K and that's part number. That's a diff, right? Because otherwise we'd have to store like the same information every time. Otherwise, and then you would just have all this variant information in the board file that wouldn't be necessary to generate the exact same output. It'll be transparent. You can select all 4 and change it. You won't notice the difference. Internally, it'll just be the new part for every variant. I don't. I know it seems confusing, but I don't think it's really that confusing because it's just like I said. If there's no difference, it's not the definition of a variant. It's different than the base. If it's not different, it's not a variant. Thank you.